Hi there, welcome to the third video in the quadratics topic at higher. What we're going to look at today is a little bit of revision, but it's looking at the discriminant within the quadratic formula. Okay, so we want to be able to use the discriminant to find the nature of the roots of a quadratic function. Now, this is something we can already do from National 5, but it is really important at higher as well, and also links in really nicely to a couple of other things that is coming up. So I just want to go through it properly once more. Okay, so firstly, we're going to just investigate the quadratic formula, which we have here. And specifically within these three functions, finding where each of these functions cross the x-axis. So what I'm going to do here, I'm going to use the quadratic formula. Now, some of these will factorize to solve this. Okay, finding where each of these functions cross the x-axis, and don't worry about copying this down as a note. This is just something that you can kind of listen to and try and follow. Okay, so solving these three equations using the quadratic formula. The first one, the solution x will be given by, when you sub in a, b and c, it will simplify to -4 plus or minus the square root of 8 over 4, which gives you two answers. Okay, x equals -0.29 and x equals -1.7. Okay, so those are the two possibilities that come from that quadratic. So that quadratic cuts the x-axis in two different places. Okay, it cuts it at -0.29 and -1.7. The second one, when you find where it cuts the x-axis, simplifies to the quadratic formula 4 plus the square root of 0 plus or minus the square root of 0 over 8, which gives you, when you add on root 0, it gives you a half, and when you take away root 0, it also gives you a half. So what's happening there is, for your x-axis, your quadratic has just got one single point of intersection, because there are two answers that are the same coming out of that quadratic formula. And finally, for this last one, you do -1 add or subtract the square root of -39, it will become all over 10. Okay, now that gives you no solutions. That does not work when you go to put it in your calculator. Okay, which means for our x-axis, this quadratic does not have any x-intercepts and just floats above the x-axis. Now, the key to what's happening here, these are your three possible situations. Either it's going to cut it twice, it's going to hit it just at one point, or it's not going to hit the x-axis at all. And the key to telling us that is underneath the square root in here. Okay, if that number there is positive, then when you add and subtract, you're going to get two different things, which gives you two different answers. Okay, hence your two roots. When it's 0, adding and subtracting doesn't make a difference. You're still going to be at the same place. When you add 0 and take away 0, this is still going to be 4 in your numerator. So that gives you two equal roots, two roots of the same, essentially one answer. And lastly, because that's a negative number underneath there, that doesn't work. You can't get the square root of a negative number, not in the real numbers. So that gives you no solutions, which means there are no points of intersection. So that bit of the quadratic formula in here, which we know is a discriminant, tells us not what the roots are. It doesn't tell us if it's going to be a half or -0.29, but it does tell me the nature of the roots. In that, is there 0, is there 1, is there 2? Okay, and we call them, in this case on the left-hand side, that's real and distinct roots, because they exist and they're different. These are real and equal roots because they exist but they're the same, and this is no real roots at all. Okay, so real and distinct, or real and equal, no real roots. Okay, now I'm going to put this up. This is a note. I'd like you to copy it down for me. It's a bit long, so I'm just going to get you to pause it there, and then I'll move it down a bit. There. And finally there. Now, the only extra bit of information I've got on there is this bit at the bottom. If b squared is a perfect square, the roots are rational, otherwise they are irrational. Okay, what that means is if it's a perfect square, then when you square root it, you're going to get a number. Like if it was 16, the square root would give you 4. If it's not a square root, it's going to be a surd, which is an irrational number. So just an extra wee kind of a wee bit of bonus information. There you go. So nice, haven't I? Okay, so let's just look at the one example because it is a bit of revision. Find the nature of the roots of 5x squared plus 3x plus 2 equals 0. Now notice it's not asking for what the roots are, it's just asking for the nature. So that means we only need to use this discriminant. So b squared minus 4ac, we don't know if it's equal to anything yet, or we don't know what it's equal to, so I'm not going to make any statement at the start. B is 3, so 3 squared minus 4 times a, which is 5, and c, which is 2. A in front of the x-axis, and 3 in front of the x squared, b in front of the x, and c, the constant at the end. Now this gives you 9 take away 40, which is negative 31. Okay, which we know now, well, it's a negative number, so that won't work. So there's nothing happening, there's no x-intercepts, there is no real roots. Now your statement then should be that the discriminant is less than 0, therefore no real roots. Okay, and that's your statement that you have to make to get your marks. Okay. Now that's it. As a bit of revision, I'll just leave that there. We'll look at the discriminant in much more detail into the kind of more higher level stuff in the next 2 videos, but you'll get a bit of practice with that, and let us know if you get any issues. Thank you.